Okay, so we're going to go through this, and this is just a really good overview of where we should be at with statistics. Statistics is just somebody gives you data, and that's a total disaster. It doesn't mean anything to anyone. We're supposed to be able to take it and graph it, and then once we graph it, describe what we see, and that should help us make good decisions about whatever it is we're studying. Okay, so this is a list, excuse me, of 20 randomly chosen New York workers, and these are their commute times. And so I wanted to do a Stemplot because some people were still confused on how to do a Stemplot graph. And so all you do, let's just draw a line down here. A Stemplot is pretty easy. You just want to find your smallest number in the list, which would be 5, and then your biggest number, which would be 85. Okay, and what we're going to do is we're going to choose a stem. Well, these are all 2-digit numbers. And so our stem's going to be 1 digit, and then the leaf parts are going to be the other digit. Okay, so we're going to go from, remember this number 5 is actually 0, 5. So I'm going to start at 0. And I have to go all the way up to 8 to get to be able to write 85. So the rule is you cannot skip numbers. So you have to just go in sequence 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so these are called our stems. And then our leaf is just the other part of the number. So to make the number 5, that goes with the 0. And so that represents the number 5. You guys okay with that? Okay, so then we go to all the numbers that start with the digit 1. So there's a 10. There's a 10. So I've got 2 10s, so I'm going to cross them out as I go. And I'm going to put 2 zeros, right? Because remember, this represents the number 10, and that's another 10. And then I keep going, and there's a 15, and a 15, and a 15, and a 15. So there's 4 15s, so I need 4 5s. So I know most of you have done this before, but again, Keller, what this is doing is it's graphing all of these numbers in a particular way. This represents the number 10, 10, 15, 15, 15, 15. Okay. All right, so then as we go through the 20s, right, we've got a 20, a 20, a 20. So 3 20s, so 3 zeros. And then 25s, I've got 1, and that's it. Okay, then we go on to the 30s. We've got a 30, a 30, so 2 zeros. And did I have any 35s? No. So then I go down to 40. There's a 40 and a 40, so 2 zeros. But I also have a 45. As I look for 50s, there's no 50s, which is okay. You just leave it blank. 60, 60. So 0, 0. And then the last one there would be 85.
There's a 65 on there.
Oh, there is? Oh, thank you. Perfect. 65. Okay, and so when we did a Stemplot, and again, this is a great review, right? Because we just took a quiz, but the ultimate goal is the assessment at the end of the chapter. So part of graphing data was a simple dot plot. Then we learned how to do this guy. Well, when you do this guy, we would always do a key, right? So we would say, just pick any number. I'm going to do 2/0. And really what that represents is a 20-minute commute. And all that does is that someone who looks at your graph, they now understand what all these numbers are. Okay. All right, so first part of the introduction to statistics, take a bunch of data and graph it. Okay, this is one of the graphs we've learned. The next part is to describe. And when it says describe in stats, you don't have an option. You have to follow an acronym SOCS, S-O-C-S. And you guys know that if you've been paying attention. And so how do I do that? Well, I'm going to turn this sideways because now it makes more sense to me, like numerically, right? This is like a number line, right? 0 to 8, x-axis increasing to the right. And if you draw a smooth curve over the data, okay, that's how we kind of look at the data. That shape is what we called skewed to the right because it has a tail that goes to the right. Okay? And so over here, when we talk about shape, that's our first acronym. Shape would be skewed right. The O of our acronym for SOCS represents outliers. And, up until this point, we're actually going to find outliers later. Up to this point, we were just supposed to look at the data and be like, hey, is there any data that looks really, really far away? I mean, there's some gaps here, but it doesn't look extremely far away. So we would probably say no apparent outliers. You're just addressing that you looked at it. Oops. No apparent outliers. The C of the acronym stands for center. And so at this point, what I want to do is we're going to move away from finding mean and median by hand because it's ridiculous. We have calculators, we have websites. And so what I want to do, you guys, and when you watch the notes today or whenever you get to it, you'll go to this descriptive statistics website and you can see that the data is already there from last period, which is super handy. So all you would do when you go here is you click on this box and you type in all the data points, okay? This is another type of graph that we learned how to graph. This is called a histogram. But you guys can see that this solidifies what we said, right? Skewed to the right. So same data. Super easy to find measures of center, which are median and mean. If you scroll down right here, you've got the median, 22.5. And down below, you can see sample mean is 31.25. Okay, so I'm going to write that on the notes, and then I'll click back over. So you can write down that the median is 22.5, and the mean of the data is 31.25. Okay, so all I did was I added back in the mean and the median that I can find from a website. Super easy. Okay, so SOCS, SOCS. The last one stands for spread. And this is just asking you, right? How spread out is the data? Does it go from 0 to a gazillion? No, it goes from 5 to 85. And a really easy measure of spread that you've already learned in your life is called the range. So you would say the range is 85 minus 5, which is 80. Okay, now this is notes. I talked about on a quiz, right? Stats is about writing sentences, okay? And people who are good in English do really well with statistics because they can contextualize things. So on an actual assessment, you don't want to say just skewed right. You want to say the distribution of commute time for the New Yorkers is skewed to the right. You don't want to say, no, this is okay, it's close. You can say the data do not appear to have any outliers, right? Try to turn it into some type of sentence, right? The median of the data is 22.5 minutes, while the mean is 31.25 minutes. The range of the data is 80 minutes. Something, as far as a sentence will be better. Okay, and all of that, nothing is new. Okay, that all was tested on the last quiz. Okay, so then if you start the lesson from Tuesday, if you guys watch it after we're done here, it'll go really quick. It's super easy. It wants to focus on the median and the mean. Okay, and there's just some basic stuff that happens here. Okay, so let's draw 3 graphs, or 3 main graphs. We have symmetric data, and we have skewed right and skewed left. Okay, so what are these? These are called smooth curves that would lay over data that we collected. If you end up with symmetric data, the mean, which is the average, and the median are the same. They're right in the middle. But something happens when you have skewed data. So let me give you an example. So house prices in San Diego, and you don't have to write this down. We're just going to talk about it. So let's say you guys graduate from somewhere, I don't know, Arizona. So you graduate from ASU. You've never been to San Diego in your life, but you're like, I want to surf. That's my lifelong goal. I want to go live in San Diego. If you guys go on the internet and you look up the average, remember average is the mean, right? The average house price in San Diego, it's going to say something like, I'm kind of making this up, but I would guess it's somewhere around here, $780,000. And you'd be like, never mind, right? Can't afford to live in San Diego. That's insane. Okay, that's over $750,000. There's a reason why when you type in the average home price in San Diego, they won't even give you the average. They will report the median. So it'll say the median home price, and that would be more like, call it $420,000. These are drastically different. And the reason that the real estate market reports $420,000 is because the median, remember, is the middle of your data. That's super helpful if you want to move somewhere. Because let's say your budget is $400,000, right? 50% of the homes in San Diego County cost less than $420,000. 50% of them cost more, but to me, this means, look, half of the houses there I can choose from, I can buy. So I can find somewhere to live. Does that make sense? And so what's up with that? Well, I mean, you guys think about some of the homes that are up on Mount Helix, right? Top homes, massive, they're probably a couple $1 million. That's chump change to when you go to La Jolla or Del Mar and you get a house that's on the cliff right there. Those things are $15 to $20 million. And so you have a lot of houses that are around $400,000, $500,000, $600,000, but then you have these massive mansions in Rancho Santa Fe and Del Mar and along the coast that bring the average way up. Okay? And so home prices in San Diego look like this. There's a lot of homes, right, backed by 500K. But all of these multi-million dollar homes are going to pull the average, right, up. And so what happens with skewed graphs is the mean gets pulled towards this tail because of those extreme values. Okay, and so on our data here, the median would be back here, and the mean would get pulled towards the tail. If this was our data, the mean's going to be pulled this way, and the median is back there. And all of that goes back. Check it out. The median is 22, and the mean is 31. So isn't the mean bigger than the median? Because we said it was skewed to the right. So these large values are pulling that average up. And so we wouldn't want to report the mean as a measure of center on skewed data because it doesn't tell the whole picture. Okay. So the last part down here is we have these new terms here, the 5-number summary, IQR, and then we're actually going to be able to check for outliers. So before we get into this, let me draw some pictures. Again, you don't need to draw this stuff down, especially now that this is being recorded and you guys can check it online. But let's just do some basic stuff here. So if I do a number line like this, you guys okay with that being the minimum and that being the max of something? Right? Those are words we understand, the maximum value, min value. And then we've already talked about the median, which is halfway. Okay? And so another way to think about this would be this is 0% of the way, this is 50% of the way up, and this is 100%. Okay? So intuition tells us right here, this is called quartile 1. Well, you guys are old enough now where you've dealt with money, you probably have jobs, you know that a quarter is 25 cents, a dollar is 100 cents. And so when I say the word quartile, it aligns itself with 25%. And then right here, we call this quartile 3, which would be 75%. This right here is what we call the 5-number summary. Okay? And so when I ask you guys to report the 5-number summary, it's super easy because you know it's just the min, median, max with the quartiles. You go back to your descriptive statistics, and they're all right here on this webpage. So we have it all right there. Okay, all we're going to do is write it back down. So I'm going to take these numbers, and we'll write them down here. So I have that my minimum is 5. My quartile 1, 25% up, was 15. My median was 22.5. Quartile 3 was 41.25. And my max value was 85. So that is the 5-number summary. Again, the focus in this class is not finding those numbers, right? Just type it into a website and get them. We're going to figure out what to do with them and how to use it to describe stuff. So then we're going to go into IQR. Well, that's same thing. It's really easy. I think you guys know, back to that same diagram, the distance from the min to the max is called the range, right? From mathematics. Yeah, we just did that one. Okay, so what if I put quartile 1 and quartile 3? The distance between those two is what we call interquartile range, which is just IQR for short. And once you see this picture, it's really easy. I don't think it's confusing to your brain. The range was the max minus the min, right? So the range is all the way. The interquartile range, it's still a range. You still do the top minus the bottom, but it's of the quartiles. And so IQR is quartile 3 minus quartile 1. Okay. And so we know that the IQR is equal to quartile 3 minus quartile 1. And so you would say it's 41.25 minus 15. But again, you guys don't even have to do this because look, if you go back to your descriptive statistics, it's right here. See that? So you don't even have to do it. You can just report it. You know, it tells me that it's 26.25. So that website gives you everything you need to know. You can just report that the IQR is that. Okay, so why all these numbers? So tomorrow what I'm going to do is I'm going to do the last real graph of this chapter, which is called a box plot. And you guys might have seen a box plot. It looks like this, like a rectangular box and whisker plot, something like that. Yeah. If you haven't, it's okay. It's not hard. But we're going to use the 5-number summary to graph it. But what we're going to do right now is we're going to find outliers. So remember, up here, we said no apparent outliers. You guys don't have any idea how to say with certainty that there is or is not an outlier. Okay. Now I'm going to give you the mathematical way to say, yes, for sure, there's an outlier. So it is an outlier if ... Okay. So something is an outlier if there is a number that is bigger than quartile 3 plus 1.5 times the IQR. Or if it's a number that's smaller than quartile 1 minus that same thing. So remember, your position in this class is you're going to take all your assessments online, which means you're home, you have notes. So you have this written down next to you, right? Outlier, how to find an outlier. Here's a perfect example. Okay, you shouldn't freak out about IQR, quartile 1, or quartile 3 because you have that website where you just type it in and you get those data points, right? So let's check to see if there are any. So let's do the first one. Quartile 3 was 41.25 plus 1.5 times IQR. And that will give you a number. And that number is going to be 80.625. What the heck is that? What that is it says, okay, go back to your data. Yeah, if there's any number bigger than that, it's an outlier. And so you guys know that 85 was there, right? And so you would say since 85 is greater than 80.625, it is an outlier. Okay, so now we know for sure that 85 is an outlier. So that's a number that possibly is too big. Now let's check too small. So if you do quartile 1, if you do, we're checking the other one now, right? 15 minus 1.5, you get negative 24.375. And there is no number less than that. Yeah. Go back in time. And this happens a lot, right? It's just saying, look, your data's okay. You don't have any numbers that are way too far to the left on the low. And so this wasn't wrong at this point, describing it, right? But now we have a mathematical way to actually find it. And so as I write these notes, you guys can see, hopefully see where this quiz is going. So on Friday, you guys are going to have a quiz review. I'm literally just going to open up one of the multiple stats books I have and go find some data, right? And I'm going to say, okay, here's some data. Go type it into this website, right? Descriptive statistics, and you get your histogram. So if you type that in and you get this, you should be able to describe it, right? Very easily. Then I can do exactly what I just did here. I can ask you guys to go in and come up with your 5-number summary, right? Show me your mathematical work for an outlier. You have to check, okay? And then obviously there'll be more because there's 2 more lessons. This will cover, though, you guys, Tuesday's lesson and Wednesday's. So when you watch it, it'll be really easy now. You've seen it. You can go jump in, hit play, watch it, and then you can get going on the homework.